Okay, class, look up. So just like I told us previously, I said for atomic spectrum, when you actually pass electric current into a discharge tube that has hydrogen gas, and then of course you display it on a screen, you're going to see lines of different colors. Now those lines of different colors, just like I told us that every line, every color that you know in this planet has a wavelength, right? Now, so for us to calculate those wavelengths, a formula was developed by Rydberg. I believe you must have seen something like this before. Now this is Rydberg equation. Now this is 1 all over lambda. Lambda here is the wavelength equals to RH in brackets 1 all over n1 square minus 1 all over n2 square. Now this constant, most of the times they will always give you guys this constant in exams hall. But what if they don't give you the constant in exams hall? You actually have to know this constant. 1.90677 times 10 raised to the power of 7. Now this n1 and n2 is actually where there will be a problem. This is actually where we're going to have some problems. So different persons actually jumped on this particular calculation. This calculation was developed by Rydberg, but different scientists actually, modified this particular formula. So let's look at that. Please look up. Line series. Now a lot of scientists came up with their series formulas. Now when I was in school, there is this acronym I used in remembering all the line series. Low blood pressure brings pain. All right, so low is the Lyman series, and this guy Balmer, this guy, have you seen something like this before? Now this series of lines basically is what we need to use to solve this. Now this particular person realize for Lyman series, the value for n1 is not going to be the same thing for Balmer series. So n1 for these guys, this guy n1 is 1 for Lyman, n1 for Balmer is 2, n1 for pass chain is 3, n1 for bracket is 4, n1 for this guy is what? 5. Yeah, it's P font. There's also the one we call Humphrey, but that one is out of reach. Please, anytime you're asked to calculate the wavelengths in a line spectrum, they must always mention any one of these guys. They can't just ask you to solve for wavelength, because this way the scientists that actually further develop this stuff, each of them have different formula, different perspective. So if you're asked to solve for the wavelength of light, maybe for the third line, remember I said there's what we call line spectrum, there's what we call continuous spectrum. Line spectrum is a case of hydrogen spectrum, where if you actually carry out electric current and discharge it into a tube that has hydrogen gas, there will be a display of lines. Those lines have different colors. So it's going to be like this, it's going to be like this, it's going to be like this. Lyman conducted that experiment and got series of lines. Balmer conducted the experiment and got series of lines. Paschen conducted the experiment and got series of lines. All right. So they might ask you to solve for the wavelength of the third line, the second line, or the fourth line, as the case may be. So all of this is what we need to solve for. But take note of this. Anytime you're asked to solve for wavelengths, they must mention any one of these guys. If they say Lyman, your N1 automatically becomes what? 1. If they say pass chain, your N1 automatically becomes what? Now, N2 plus the first line for Lyman is going to start from 2. It's going to start from what? Please just stop writing. Lyman, the first line for Lyman is going to start from what? 2. Second line will be what? Third line will be what? 5. So now look at this. If you're asked to solve for the wavelength of the second line in Lyman series, first of all, this guy is a constant. So you don't have to bother about this. You need your N1. So for the fact that they say Lyman series, N1 becomes what? 1. Now, since they said second line, class, for Lyman series, first line is what? Second line is what? That is it. So even if they say 10th line, just keep on increasing it. If N1 is equals to if N1 is equals to 1, right? First line for this guy will be what? Second line will be what? Third line will be what? Fourth line will be what? 5. Now, for Balmer series, what do you think will be the first line? 3. Second line will be what? Third line will be what? Fourth line will be what? This continues. For pass chain series, for pass chain, since N1 is equals to 3, first line for this guy will be what? Second line will be what? Third line will be what? 7. For this guy, what do you think will be the first line? 5. Second line will be what? Third line, fourth line. For P-phone, what do you think will be the first line? 6, 7, 8, 9. So that's basically how we get these values. So if you're asked to solve for wavelength, they must mention the series of lines in question. The question says, let me write it out so that we have question 1. They said, I want to modify the question. In the past question, they said wave number. But I want to modify it to wavelength and also the wave number, so that I'll use one stone to kill 2 birds. Right? So I'll say the wavelength and wave number, okay? Or it's the same, okay? Wavelength and wave number of the 5th line of bracket series for remember this was carried out for hydrogen. This is for hydrogen spectrum. So most of the times they might attach hydrogen to that guy. Class, this type of questions, I don't usually solve plenty examples. Highest, I'll solve 2 examples. But I'm going to take time to make sure you understand each example. So look at this question here. They said the wavelengths and wave number of the 5th line of bracket series for hydrogen gas is that. Just like I told us previously, that if you're asked to solve for a particular wavelength of any line, they must mention any of these series, because these are the individuals that actually carried out this experiment and came up with data. So I cannot just come out and just give us without mentioning any one of them. So first thing first, once you're asked to solve for this, I'll say solution. I know fully well that I'm going to use a Rydberg equation. So I'll say for bracket series. Class, for bracket series, N1 is always equal to what? 4. This bracket series. Now, they said for which number of lines, class? 5th line. Now, if this guy is actually the first line is going to be what? Second line will be what? Third line will be what? Fourth line will be what? 5th line will be what? 9. So I'll say here, so therefore, my N2 will be equal to what? 9. But what if in exams, you have to start writing all of this stuff? N1 is this, N2 is this. Yes, some persons might do it, but then me, I don't used to do it actually. I'll just add it up. I'll just do what? They said we should calculate for the what? For the 5th line, right? The N1 for this guy is always what? 4 plus 5 plus 3 is how many? 9. Now, so that becomes this. So what if we were asked to solve for pass chain? Let's say, for example, I was asked to solve for the 3rd line in pass chain. Pass chain is N1 equal to 3, right? First line will be what? Second line will be what? Third line will be what? So 3 plus 3 is how many? 6. So if they are asking me for 3rd line, I'll simply say for past chain, N1 is always equal to what? 3, right? 3 plus 3 will give me what? 6. But please, before you do this shortcut, you can always correspond or verify it with the what? Because me, in exams, if I know that I have enough time, I'll do this thing. I don't want stories. Even if I do this guy, I'll still do what? Confirm. All right, so I've gotten my values. I know that my RH is always 1.09677 times 10 raised to the power of 7. Please, you need to have this offhand. Most of the times, they used to write it as 1.09677. 1, 2, 3, 4, 5, 6. Most time they used to write it this way. But just know the value. The most important stuff, so let me clean up this so that we need to solve this in a way that everybody will understand. So I'll come here, I'll say 1 over this is equals to RH 1 over N1 square minus 1 over what? Let me state this categorically. 1 over lambda is this, which is a what? So if you're asked for the wave number, it simply means you don't have to start making this guy subject of the formula. But if you're asked for the wavelength, this guy is a what? Wavelength. So it means that whatever you have here, right, you have to take the reciprocal of that guy. Do you understand what I just said here? Now let's start. Let's do this guy first. I'll come back to that. So let's insert our parameter. I'll say 1 over lambda equals to, anywhere I see RH, I'll put the Rydberg constant, 9677 times 10 raised to the power of 7. 1 all over, what was our N1? 4. That is 4 squared. Minus 1 all over, what is our N2? 9 squared. Please, your calculator should do justice to this guy. Please, like if I'm solving here, I'll say 1 over this. But if I have my calculator, this is not necessary. Do you know I can press everything and get my answer directly? So please, can you give me the entire answer? From what I solved here, 1 all over lambda was equals to 550,192.90. All right. Remember, they asked me for wavelength, right? And wave number. Now, I would have said, I would have interswitched them. Please look up. This stuff you have here, 1 all over lambda, is wave number. 1 all over lambda is what? So for wave number, this is my final answer. So I'll say, note, this is not necessary, but I'm just saying 1 all over lambda is always V prime, which is what? Which is wave number. So therefore, wave number is equals to 550,192.9. That is it. V bar. So this is our wave number. So what I just saw for now is for wave number, which is I actually jumped to the second question before solving for the first question. So let's solve for the wavelength. 1 all over lambda equals to 550,192.90. Lambda becomes 1 all over. Please, if you cross multiply and make this guy subject of the formula, that's what you're going to get. So this becomes 1 all over 550,192.9. Please do this for me. minus what? 6. Please stop writing. Everybody stop writing. 1.8 1.8156 times 10 to the power of minus 6. Give me calculator. 1.8175. Please stop writing and pay attention. I'm about to do something now. Wavelengths always have a unit of nanometers because meter is actually too big for wavelengths. If you measure light, if you measure wavelengths, if you take most of the places wavelength calculation is mostly done, apart from the electromagnetic spectrum, where you have lambda, velocity. Now here, the unit of these wavelengths should always be in nanometer. Class, nano is 10 raised to the power of minus what? 9. So, but we already have minus 6, is it not so? Can we take this guy to minus 9? Yes. If I move this decimal point 3 places forward, right? Class, if I move the decimal point, how many places forward? I will now make this guy to be what? Minus 9. So that if I want to go back to that, I'll divide by that 3 zeros that I added. So now look up. Here becomes equals to, I move this guy 1, 2, and what? 3. This now becomes 1817.5. Class, look up. This was 10 raised to the power of what? Minus 6. This movement I did is like saying 10 raised to the power of what? Because if you actually say this times 10 to the power of minus 3, you go back to this. Right? So minus 6 minus 3 now becomes what? Minus 9. So therefore, and 10 raised to the power of minus 9 has a what? Is nano, right? The symbol or sign for nano is what? N. So this guy now become 1817.5. All right, let's look at the next question. They said, what is the wave number and wavelength of the fourth line in Balmer series for hydrogen? What is the wave number and wavelength of the fourth line in Balmer series? So solution, I'll say for Balmer series, class, what is N1 for Balmer series? N1 for Balmer series is always 2, right? Now, they said, which line? For the fourth line, class, let's check out that shortcut I told us earlier. Fourth line will now say 4 plus is how many? So for the fourth line, N2 will be equals to what? Now let's verify. For Balmer, N1 is equals to 2. N2 for first line will be equals to what? Second line will be equals to what? Third line will be equals to what? Fourth line will be equals to what? 6. So that is correct. It corresponds. All right. Using Rydberg equation in exams, this statement is not necessary. This becomes 1 all over lambda RH 1 all over N1 squared 1 all over N2 squared. All right. So we have this 1 over lambda equals to 1.09677 times 10 raised to the power of minus times 10 to the power of 7, not minus 7. All over 1, N1 was 2, so this is 2 squared. Remember, here N1 is 2, so it's squared minus 1 all over N2 is what? 6. That is the fourth line, isn't it also? You square this guy. So this is equals to 1 all over lambda 1.09677. Class, this is 1 over 4 minus 1 over 36. Please, I need your calculator here. says what? Everything here note that 1 over lambda is wave number. So therefore, wave number is equals to 2437266.7 meters. Now that is a wave number. So in exams, once you're asked for the wave number, that becomes very easy. Whatever you have as 1 over lambda, that's equals to your wave number. Now, okay? So let's solve for the wavelength now. Remember they said wave number and wavelength. So what we just solve for now is the wave number. So if you want to solve for the wavelength, for wavelengths, I'll say from here now, from here, 1 all over lambda is equals to 2437266.67. Now wavelength is this guy. So if I should make this guy subject of the formula, it's more like taking the reciprocal of this. All right. So if I should actually do over 1, then cross multiply, lambda, which is the wavelength, equals to 1 all over 2437266.67. Class. That will now give us 4 point what? 10 times 10 raised to the power of what? Please look up. Remember what I told us earlier, that wavelength is best represented in nanometer, isn't it also? Wavelength is best represented in nanometer, and nanometer is 10 raised to the power of what? -9, right? What we have here is minus how many? 7. So how many decimal places forward are we going to move? 2. Class, take note of what I'm telling you guys. If it is -6, you have to move it 3 places forward. If it is -8, how many places forward? 1. -5, how many places? 4. -7 is now going to be how many? So this becomes wavelength equals to 410 what? So now what we just did here is look up. If you move it 2 places forward, this now becomes 10 raised to the power of minus what? 9. And everything here, 10 raised to the power of -9 is nano. So this now becomes 410. In place of times 10 raised to the power of -9, you now put what? Nano. And then you add the meters. So that becomes the answer. Sorry, I'm writing it down. Just let me write it off for those persons at the back. At least I've captured that part. So this is what I mean. We got our wavelength to be 410 times 10 raised to the power of -7 meters. And I said wavelength is best represented in nanometer. And nano has a value of 10 raised to the power of -9. We already have -7 here. So what will I do to this guy to make it to be 9? I'll move, there is a point here. I'll move this point 2 places forward. So when this becomes 1, 2, we now have 4.1410 times 10. Instead of -7, we now have what? -9. Class, 10 raised to the power of -9 is same thing as saying what? Nano. You now add your meters, so that is what we got. So with this now, class, we are done with this calculation here. So like the part that has to do with definitions of terms, I'll just keep those parts. Let's look at dilution. Please put down. Dilution involves addition of solvent to a solution, resulting in an increase in the volume of the solution and a decrease in the concentration of the solute in the solution. Now the formula for dilution is as follows. We have M1 V1 so there are two ways questions can be asked based on dilution. The two ways are as follows. The first one is, please pay attention. If they ask me, what is the amount of water needed to dilute a particular solution? So let's say, what is the amount of water needed to dilute is different from what is a final volume after what? Dilution. Do you know there are two different questions? So let's take down this question so that to save time, please put down 100 ml of 2.5 molar KBr solution. What is the final volume? What is the final volume of the solution? 100 ml of 2.5 molar solution. This is actually the one that is more concentrated, because initially we have 2.5 molar and then you are asked the final volume if this guy is diluted to 0.55. So my V1, which is the volume of the initial solution, is 100 ml. My M1 is 2.5 molar. Now M2, that's the final, is 0.55 molar. They are asking me for the final volume, V2. Class, if they had asked me for the amount of water that is needed, it would have been V2 minus what? V1. So we'll come here, we'll say, so therefore, M1 V1 equals to M2 V2. Now make V2 subject of the formula. This becomes M1 V1 all over what? M2. M1 is 2 point what? 2.5. V1 is what? M2 is what? Molar cancels molar, leaving us with. So the final answer for this guy would be 454.4 mil. So this is the final volume. Class, this is a final volume. What if they had asked us for the volume of water added? Class, the volume of water added here or needed for the dilution would have been, volume of water needed would be V2 minus what? V1. So let's check how many the amount of water that was added to that guy. Our final volume is 454.4 minus what? Minus 100. This is final, this is initial, right? So this is 354.4 mil. So it means that 354.4 mil of water what was added, right? For us to get the what? The final volume. We have a question, another question 2. How many milliliters of water are needed to dilute this guy? That's the different nature of questions. Please look up. Now, first thing first, you cannot just solve for the water volume. You need to solve for the final volume using M1 V1 equals to M2 V2. Once you've gotten your V2, you now say V2 minus what? V1 to now give you the amount of water that we need. So we say, how many milliliters of water are needed to dilute this? We'll soon start. After now, there is the last example. So V1 is 80 mil. M1 is 5.0 mil. Sorry, this is molar. Now M2 is 1.0 molar. V2, this is not what I'm asked to find, by the way. But for me to be able to get the amount of water that is needed, right, I need to solve for my what? V2. So I'll now say M1 V1 equals to what? M2 V2. Now make V2 subject. This becomes M1 V1 all over M2. So what is our M1? What is V1? M2 is what? This cancels this. And what is the answer here? 400 mil. This is the final volume. So therefore, amount of water needed to dilute this guy would be V2 minus V1. They are asking me what is the amount of water that I will add to this 80? So here, the amount of water needed will now be V2 minus V1. What is our V2? What's our V1? So what is the amount of water that is needed? So this is the amount of water that was added to actually achieve this.